Hello friends, welcome back. In the previous class we have seen how passing a parameterized constructor works with the structures. We have understood. Now we get the information with the class. Parameterized constructor in class, how it works. We are going to save this and I just come back to Unity. I run the code. We got P1x is 10, y is 20, P2x is 30 and y is 40. Previously we have seen how do the parameterized constructor in structures works. Now we are going to see how parameterized constructor works in a class. So I am going to copy this code, come to the paint and I paste the code. Now of course when I am working with the reference type, I will be having two different memory blocks, memory structures. One is a stack, another one is a heap, right? So I will be working with the stack and heap now, or you can say the control will be working with the stack and heap. What happens when the control executes this line? We know that point P1 is going to be created. First the start function is going to be on top of the stack, start. Now start is now on top of the stack, right? Memories will be allocated for the members or local variables of the start function. So P1 is going to be allocated here, right? That is our P1 memory location, right? And of course P1 is going to have some address. You can mention something like #1, let us take, and P1 is going to have the value null because still it is not initialized. Good. After executing this part, we are going to call the new keyword, right? The new keyword is going to get executed. What the new keyword does, it checks which constructor you are using or which data structures constructor you are calling. You are using the point class. So what new does, it will allocate a memory block on the heap. This memory block is going to have two parts. Why? Because we have only two members. If you have more members, then more memory blocks. So here one for x, one for y, and let us take the memory address is #10 is the address, and these two memory locations are initialized by the values 0, 0 because they are float. They will be initialized by the default value. Okay, that's good. After that we are going to call the point constructor. So when we call the point constructor, control will move to that constructor which matches the number of arguments and the types, right? Of course, when you are calling the constructor, you will be passing one extra parameter, that is the address of newly created memory location. At present it is #10. So we are calling the constructor with one extra parameter #10, that is our newly created memory location. And we also know that it is going to have one extra parameter which is of type point, and the variable name is this. And now what happens, guys, when the control comes to this place, of course we are going to have on top of the stack, we will be having the point constructor now, right? So we are going to have the point constructor available on top of the stack, and three different memory locations are going to be allocated on top of the stack now, or in the point area. One for x, one for y, and one for this. And this memory location is x, this memory location is y, and this memory location is this. We know that we are passing 10, that will be copied to x. So here you are going to have 10. We are passing 20 to y, so y is going to have 20, and we are passing #10 to this, so this is going to have #10, and now onwards this is going to point that memory location. After that, the control will start executing the statements one by one. This dot x equal to x. This dot x, we are telling that this dot x should be the value of x. So here you are going to have the value 10, right? Then this dot y should be the value of y. So this dot y is going to become the value of y, which is 20. After executing these statements, we know that we are having one last statement, that is return this. And you should remember that the return type over here we have is the point itself. As the point is the reference type, it is going to return the value of this, that is hash 10. It will return the address that is stored in the this variable. So hash 10 will be returned back to this place. You are going to get back that address hash 10, and that hash 10 will get stored in the P1. So now your P1 is going to be hash 10. Now what happens is the P1 is going to start pointing to that memory location. As the control has come back, we will not be having the point on top of the stack, and these memory locations are not going to be available. Debug.log, we are displaying the value of p1.x, which is 10, p1.y, which is 20. After executing that statement, control comes to the next statement, point p2. Now p2 is going to be created in the start area, because it is a local variable of the start function. So of course we will be having one more memory block, and its name is going to be p2. Maybe its address is hash 4 or hash 5, and it is going to have the value null inside it. After that, we know that the control is going to execute the new keyword. What the new keyword does, new keyword creates one memory block on the heap, and its address is maybe hash 14 or hash 14, let us take, or something else. Of course it is going to have two parts, one for x, one for y. So one is for x, one is for y, and these two memory locations are at present assigned the value 0, 0, that you should remember. Then point constructor is going to be called. Okay, here comes the call. So when we call the point constructor, it will move to that memory location, and of course we will be passing one extra parameter, that is the newly created address hash 14. Newly created memory location address is hash 14. And what happens, we already know that when the control comes to this place, now on top of the stack you will be having the point constructor again, right? Of course we will be having that on top of the stack, and of course you will be having three different memory location, one for x, one for y, one for this. You know that we are passing 30 will be stored in the x variable. So this is our x. Here you are going to have the value 30. Then we are passing 40, that will be stored in the y memory location. So y is going to have here 40, and we are passing hash 14 to this variable. So this is going to have hash 14. Once you store the value in this variable, this is a reference type because it is of type class, right? The point is of type class, so you are making the variable which is a reference type. Now once you store the address, it is going to start pointing to that memory location which has the address hash 14, and then the system will start executing one by one the statements. So this dot x is going to be x, so this dot x is going to become 30, and this dot y is y, so it is going to become 40. After that, return this. Of course, now what happens, the control will come back with the value of this, which is actually hash 14. As it is a reference type, it will return the address, not the value. Okay, it will return the address. So hash 14 will come back, and hash 14 is going to get stored in the P2. So now P2 is going to have hash 14 in it, once you store the address in any reference type, it will start pointing to that memory location. And once the control comes back, we know that now the point is not on top of the stack, right? These memory locations are going to be removed. As you have a reference to P1 and P2, they will be available in your code. Then we are going to execute P2 debug.log. It will display P2.x and P2.y, which is 30 and 40 on the screen. So here you can observe the difference that the return value will be the value of or value at this is pointing, whereas here the value of this, that is address, will be returned. Here the value will be returned. Here the address will be returned. Here the value will be returned. And the memories are allocated on the heap in the class, whereas the memories will be allocated on top of the stack, in the stack, in respective to structures. Okay, that is how the code works, guys. I want you people to please try to understand these two together and analyze the difference, because once you understand later while working with codes, it will be really easy for you guys to understand and analyze which type of blueprint or a design you need to create for different problems. Now let us proceed to the next step. I just close these things, I don't want them. There is the third type of constructor, which is also known as the copy constructor. Now let us see in respect to the structures. I am going to delete these things because now we are going to get the information about the copy constructors. Then later we will get other information. So this time I am creating the structure struct point, and the constructor is going to be a copy constructor. Now copy constructor is going to take the variable of the same type as the structure is, or the data structure is, you can say. So this one I can say P point. So this is going to be a type P point, and what we do here means we assign the P point value that we get, P point dot x, and this one is going to be P point dot y. This is the, or you can say here value also. This is just a variable name we are going to use. I create one point, point point, P1 is equal to new point. Of course I can use the constructor type. I cannot use the parameterized because you have only two constructors. One is the default constructors, which is always available for you at present, and another one a copy constructor. Now for copy constructor I need one more point, you can see that. So what I do better is I keep the parameterized constructor here. Okay, just make it public point float x comma float y. Here what I do, I say this dot x equal to x and this dot y equals to y. That is a parameterized constructor, another one is a copy constructor. Now what I do, I create one point using the parameterized constructor, point P1 is equal to new point, and I store the values inside it as let us take 10.0f and 20.0f. So this will create one point with the values x and y will be having 10 and 20. That we know already how the parameterized constructor works. Now let us take, I want to create another point called as P2, and I want to make this P2 exactly a copy of P1, you can say. So I can say here I can use the copy constructor point, and as we know that it is asking for a point type, so I pass here P1. That's it. This will make the P2 also having the value 10 and 20. We can see if we want debug.log string.format, I can display the value of P2, x is equal to 0 and y is equal to 1 double quotation p2 dot x comma p2 dot y bracket close. Now if I save and run, I should see p2's x and y should be 10 and 20. Let us save, come back to Unity. If I run the code, you will see that p2x is 10, y is 20. Now let us understand how this code is working. Let me copy this code and I paste the code over here. Let me reduce some lines so that we can see the code. Now we can see the code. Now let us understand how this code is working. Now we know that when this line is going to get executed, right, point P1, let me create a stack over here. And at top of the stack we have the start function. And we know that what happens when the first line will get executed, point P1. Of course, the point P1 is going to get created, right, and its name is P1. And it is going to have two memory blocks, one for x, one for y, right, and they are initialized to, let's take 0, 0. After that, new is going to get executed. What new does, we know already that it creates another point, you can say another copy, right, and this is going to have, let us take some address as a hash 10. And of course these are at not initialized, you can think like that, or they are initialized to 0, 0 we can consider. And after that we know that we are going to call the parameterized constructor, and we know that we are passing one more extra parameter always, so that is going to be hash 10. That is our newly created memory location address. And of course we will be having one extra parameter here, which is going to be out point this. So what happens now is the control will move to the point parameterized constructor, and now the point is on top of the stack. The point constructor is on top of the stack, and it has three different memory locations, one for x, one for y, and one for this. So you are going to have one for x, one for y, and one for this. After that we know that we are passing the values 10, so 10 is going to get stored in the x, and we are passing 20, 20 is going to store in the y, and we are passing newly created memory location address hash 10 will store in the this variable, so you are going to have hash 10. And we also know that once we store the address, it will start pointing to that memory location which is having the address hash 10. After that the statement starts executing this dot x equal to x, so 10 will get stored in this dot x, we know that. Then this dot y equal to y, and this is going to become 20, we know that. After that we are also having one return statement, return this, and we know that this is going to return a point back, and point is a value type, so it will return the value, not the address. So the whole value will be returned back. The value will be this, right guys, and this will be returned back to this place. So as the value is returned back, once the control comes back, we know that we will not be having the point on top of the stack. And what happens is, one by one the values will be copied. So p1.x is going to become 10, p1.x is going to become 10, p1.y is going to become 20, right? After executing that line, the control will move to the next statement. When the control moves to the next statement, of course we are not also going to have this memory location. Now we are back to the start method. Of course, next we are going to execute the next statement, that is point P2. We know that as it is a value type, it is going to create another memory block, and its name is going to be P2. And of course P2 is also going to have two parts, one for x, one for y, right? This one is x and this one is y. Good. After that we know that we are going to execute the new keyword. What new will do, it will create another point memory block, so it will create another point, right, another point on top of the or in the stack only, you can say. And of course its address will be, let us take hash 20 some address. Good. Okay, that is the operation of the new keyword. Then we are calling point p1. You can see that we are passing p1 as well as we are going to pass one more parameter, which is the address of newly created memory location, which is hash 20. So hash 20 will be passed over there. We know that we are going to call the copy constructor because we are passing a point and this is asking for a point. That's it. And we also know that we are going to have always one extra parameter available, which is actually out point this. Now what happens? We know that when the control comes to the point constructor, which is a copy constructor, now we are going to have on top of the stack point constructor, and it is going to have two memory locations only, one for the point. Of course this point is of structure, so definitely we will be having one complete block which is going to be partitioned into two parts, and one for x and another for y. Okay, that is our p point. The variable is p point. This one is, I can say here I will write p point. This is our p point, which is in the point constructor now, and we are going to have another memory location which is going to be this. So here you are having this. Now what happens here when the control comes to this place? The point is equal to p1, you can say. So p point equal to p1. So what happens here, as both are value types, p1, whatever the p1 dot x is there will be copied to p point x. So p1 we are passing, that is having the value 10 now, which will be copied to p point. So p point x is going to become 10. Then p1 is p1 dot y will be copied to p point y. So p1 dot y is 20. So p point y is going to become 20. Good. After that we have this, which is going to hold the address hash 20. That is what we are passing. And once we store the address, it will start pointing to that memory location. We know that. After that, one by one the statements are going to get executed. This dot x equal to p point dot x. This dot x is going to be p point dot x. So you are going to have here 10. The next statement is this dot y is p point by y. So p point y is 20. So this dot y is going to become 20. After that, of course, we will be having one statement which is going to be called as return this. And we know that it is going to return a point which is a value type, and we know that what it returns back to us, guys. We know that it is going to return the value of this. The value is this complete block, and it is going to return a value, not the address. It is going to return the value at that address. So it returns this complete block. So that block is going to be replaced in this place. New point p1 is going to be replaced by this new value or a block returned back to us. So when the control comes back, this is what happens over here, guys. And of course, on top of the stack, you are not going to have the point. Now after that, we are going to execute that statement point p2 equal to this memory block. So what happens? p2 dot x is going to become this memory block's x. So you are going to have p2 dot x is equal to 10, and p2 dot y is going to become 20. So you are going to have here 20. Good. Now you can see we made a copy of p1, right? P2 is a copy of p1, you can say. After executing that statement, the control will come to the next line. When it comes to the next line, this block is not going to be available in the memory, will be removed. Now you have a copy. After that, you can display p2.x and p2.y, which will give you the value 10 and 20 on the screen. So this is the copy constructor, which takes a copy of another point, that's it, and it creates another point, same point you can say. I think for this class this much is enough. We will see in the next class how it works, how the copy constructor works in the class, so that we can differentiate. For this class this much is enough, guys. Thank you guys, thank you very much. See you in the next tutorial. Keep learning, keep coding.